Okay, we talked a little bit about polynomials and degrees in the last video. This one we're going to talk a little bit about functions with polynomials. And we're able to use function notation here to represent polynomials a little bit. We could write, for example, what you usually see for a function is the f of x is equal to, so we could write this, and if we put a polynomial here, we have a polynomial function. So let's say we have 3x squared minus 2x minus 5. Okay, so now we have a polynomial function. We have the f of x is equal to 3x squared minus 2x minus 5. f of x denotes a function. So in this case, what we want to think about is, how do we evaluate this? Well, what if we want to say, like for instance, what if we want to say what's the f of 2? Well, what this means is essentially we're just going to plug 2 in wherever we see x. Since this is a function f of x, we want to know the f of 2. 2 replaces x. So we would have 3 times 2 squared minus 2 times 2 minus 5. And now we can solve this. 2 squared is 4, 3 times 4 is 12. So we have 12 minus 4 minus 5, and that's 3. So essentially what we're saying, when x is 2, the value for our function is 3. So, and we can do this with different things. Let's look at another example. What if we have the f of negative 1? Well, if we're looking at the f of negative 1, what we're saying again is replacing x with negative 1. So we're going to say 3 times negative 1 squared minus 2 times negative 1 minus 5. So again, we can work through this problem, use the order of operations. Negative 1 squared is 1. 3 times 1 is 3. Negative 2 minus 1, or negative 2 times multiplied by negative 1 is positive 2. So we have 3 plus 2, and then it's minus 5, which is 0. So when we see f of negative 1 put in, we get a 0 out. So this is what we're doing when we're looking at polynomial functions in a sense. Now, how does this relate to the real world? Well, let's look at an example here. Let's say we're going to drop an object from a 500-foot tall building. Okay, this is what we're going to do. We're not paying attention to air resistance or anything. We're not getting that anal or particular about this. So if we think about the height of the object above the ground, the height above, height above ground at time t seconds is given by polynomial function of p of t is equal to negative 16 t squared plus 500. Now, so we want to find the height, so find the height when t equals 1 second, and when t equals 6 seconds. So this is a polynomial function that we can use to solve a real world problem here. We're dropping an object from a 500-foot tall building. The height above the ground at time t seconds is given by this function. So after 1 second, we want to say, okay, what's the p of 1 here? Well, for this term, it's negative 16 times 1 squared plus 500. Negative 1 squared is 1. Negative 16 plus 500 equals 484. So basically, it's 484 feet above the ground after 1 second. And what about 6 seconds? Well, the p of 6 is equal to negative 16 times 6 squared plus 500. Move this up a little bit. Negative 16 times 36 plus 500 would be our function. I'm going to have to cheat here and do negative 16 times 36 in the calculator. We get negative 576. So that doesn't mean it bored 76 feet into the ground. It just means after 6 seconds, it's on the ground. We can't have a negative number here when we're dropping an object. I mean, we could, but we won't see it fall that far into the ground. So in this case, although we have a much larger number here, we have to think about this in terms of reality and what reality means. So hopefully this explains a little bit what we talk about when we talk about polynomial functions. So be back with more polynomials. In the meantime, have a good day.